Hello everyone, this is Chaitanya. In this video, I'm going to explain data types in C. Data types specifies the type of data that a variable can store, and they determine how much space a type of variable occupies in this storage. American National Standard Institute for C supports three classes of data types. They are primary data types, derived data types, and user-defined data types. Primary data types are also called as primitive data types or fundamental data types. These are built-in data types that are provided by the programming language. And primary data types are integers, characters, floating point, double precision floating point, and void. Next, derived data types. These are also called as secondary data types, and they are basically derived from the primary data types. Derived data types are arrays, strings, pointers, and functions. Next, user-defined data types. These are the data types which are defined by the users, not by the programming language. And user-defined data types are structures, unions, type definition, and enumerated data types. In this video, we will discuss only primary data types. Secondary and user-defined data types will be discussed in the separate videos. Primary data types are classified as integers, characters, floating point, and void. So integers are further classified as integers, short integers, and long integers. For this classification of integers, it uses the qualifiers signed and unsigned. Characters are classified as signed characters and unsigned characters. Floating point data type is classified as float, double, and long double. Void does not have any further classification. Let's see what are integer data type. Integer data type represents whole numbers with a range of values supported by particular machine. The size of the integer depends on the word size of the machine. For example, in 16-bit word machine, the size of the integer is 2 bytes, whereas in 32-bit word machine, the integer uses 4 bytes. C has three classes of integer storage. They are short integers, integers, and long integers. Short integer represents small integers and they require half the amount of storage as a regular integer uses. And integer represents higher range and they require half the amount of storage as the long integer uses. Integers are specified in signed or unsigned form. So signed form represents both positive and negative integers. In signed integers, the first bit is used for signed bit and the remaining bits are used for storing the magnitude of the number. Whereas in unsigned form, which represents only positive integers, all the bits are used for storing the magnitude of the numbers. Next, for each type of integers, let's see what are the keywords, size, range, and format specifier. So here keywords are the predefined reserved word for data types used in variable declaration statement. And keywords are not used as a function name and variable name. And size, it is the amount of memory the variable going to use in bytes. Next, range, it is the minimum and maximum value that a type of variable can store. And format specifier, it is used during input and output and it tells the compiler what type of data is in the variable during taking the input using scanf or printing using the printf. Now let's see for short integers or signed short integers. Whenever we don't use qualifiers, it will assume signed data type. So for short integers, which uses 1 byte of memory or 2 bytes of memory. So here 1 byte it is used in 16-bit word machine and 2 bytes is used in 32-bit word machine. The range is according to 16-bit word machine. So range for short integer is minus 128 to 127 and format specifier is %HD. Next, unsigned short integer which uses 1 byte or 2 bytes of memory and the range is 0 to 255 and format specifier is percentage HU. Next, integer or signed integer, which uses 2 bytes or 4 bytes of memory, and the range is minus 32,768 to 32,767, and format specifier is percentage %D. Next, unsigned integers, they uses 2 bytes or 4 bytes of memory, and the range is 0 to 65,535, and format specifier is percentage %U. Next, long integer or signed long integer, they uses 4 bytes of memory or 8 bytes of memory, and the range is minus 2,147,483,648 to 2,147,483,647, and format specifier is percentage %LD. Next, unsigned long integer, they uses 4 bytes or 8 bytes of memory, and the range is 0 to 4,294,967,295, and format specifier is percentage %LU. Now let's discuss how to calculate the range of signed type. Since signed type represents both the positive and negative numbers, the maximum value is given by 2 power n minus 1 minus 1, and minimum value is given by minus 2 power n minus 1. So here n is size of the type. So it is the total number of bits used by the type. But whatever the data type we use in C, they are expressed in bytes. So size of operator or size of function, so it will give the number of bytes used by the type. So that's why it will be multiplied by 8 to convert bytes into bits, because 1 byte is equal to 8 bits. Now let's calculate the range of signed short integer. So signed short integer uses 1 byte of memory. So value of n will be 8. So minimum value is calculated as minus 2 power 8 minus 1. It is minus 128. And maximum value is calculated as 2 power 8 minus 1 minus 1. It is 128 minus 1, 127. So minimum value is minus 128. Maximum value is 127. Next, we will calculate the range for unsigned type, so which supports only positive integer. So minimum value is 0 and maximum value is 2 power n minus 1 plus 2 power n minus 1 minus 1. So here also n is total number of bits used by the type, and it is given by size of type multiplied by 8. So let's calculate the range of unsigned short integer. So unsigned short integer uses 1 byte of memory. So value of n will be 1 into 8, 8. Minimum value is 0 and maximum value is calculated as 2 power 8 minus 1 plus 2 power 8 minus 1 minus 1. It is 128 plus 127, 255. So minimum value is 0, maximum value is 255. So next, let's see what are floating point data type. So float is a data type that supports floating point numbers, and it is stored in 4 bytes of memory, and it has 6 digits of precision. For example, if I take a 32 has a floating point number, it is expressed as 32.6 zeros in the decimal part. Next, double data type, which is used to represent floating point numbers with higher range. So that's why it uses 8 bytes of memory, and it has 15 digits of precision. So that's why it is called double precision numbers. So this is the example for double data type number. So 32.15 digits of precision, 15 digits in the decimal part. Next, long double, so which represents the floating point number with the range higher than double precision numbers. So they uses 10 bytes of memory and 19 digits of precision. For example, 32.19 digits of zeros or 19 digits in the decimal part. Now let's discuss for each type of floating point data type, the size, range, precision, and format specifier. So for float data type, so the size is 4 bytes. It uses 4 bytes of memory and the range is 3.4e minus 38 to 3.4e plus 38. So it is in exponential form. The decimal form is 3.4 into 10 power minus 38 to 3.4 into 10 power 38. So precision used for floating point data type is 6 digits and format specifier is percentage %F. Next, double data type. Double data type uses 8 bytes of memory and the range is 1.7e minus 308 to 1.7e plus 308. And precision is 15 digits and format specifier is percentage %LF with lowercase l. Next, long double, which uses 10 bytes of memory and the range is 3.4e minus 4932 to 1.1e plus 4932. And precision is 19 digits and format specifier is percentage %LF.